Hello, Culinary Chemistry. We're going to go through a whole bunch of slides, 66 slides in all, talking about beer. I have culled this from my libations class last semester, and there's a ton of information in here, and the slides are out on the Canvas site as well. The other thing I'm going to focus on is trying to make our little videos less than 15 minutes. That will allow me to put them on YouTube and get the closed captioning done without my having to go through every word I say. So let's start with the finished product. And it's been a bit of a surprise. Right around Super Bowl time, Budweiser, with their product Bud Light, did a remarkable thing. Nobody before had put an ingredient label on beer. And you can see, beer's not real complicated. There's 4 ingredients. There's water, there's barley, there's rice, and there's hops. And as far as all this nutritional information, it's a bunch of zeros. You can see there is 110 calories, which isn't a lot. There's a little bit of protein, but why did they make this play? Well, if you remember, Bud Light was trying to make a big deal that some of the other beer manufacturers were putting corn syrup in their beer. Corn syrup, as you might remember from when we watched Fed Up, corn syrup has a bad name with a lot of people. So Bud Light was making a play for market share, trying to make this move and get people off of other products that had corn syrup to their product that didn't have corn syrup. Clever, not sure that it worked, but I'll bet they're still doing it because it's easy to put a label on a box. It's relatively free. So let's move into some fundamentals of alcohol because we have not talked about the alcohol molecule yet. That molecule is ethanol. And all this drinking ethanol stuff probably started about 150 million years ago. And there was no sugar cane and there was no barley. It just kind of started happening. So why produce ethanol in the first place? Well, in order to figure this out, you got to think like a plant, you got to think like yeast, you have to think like inanimate objects. Ethanol is a chemical weapon. And in the era of the coronavirus, you guys know you're being recommended to use a lot of hand sanitizer as well as washing your hands. That hand sanitizer has ethanol. In fact, a lot of beer and wine manufacturers have converted over to making hand sanitizer because it's in short supply. So these microorganisms started making ethanol because they killed their enemies. Makes sense. It's what we do. Also, ethanol is kind of a energy source for the right thing. And in this case, we're talking about plants and small kind of creatures because ethanol fits into the realm of carbohydrates, and it is an energy source. If things get desperate, we can use the ethanol for energy if we don't have any enemies that we're trying to kill. So kind of a neat history and the beginning of ethanol a long. So alcohols in general are a group of organic chemicals, and the thing that distinguishes them is they contain a hydroxide group. Thought I switched that to my dark red marker. So here we go. This OH group is the thing that makes something an alcohol, particularly if there's only one of them. And we may recall, because we talked about OH groups when we talked about sugar, that a hydroxide group is simply a hydrogen atom covalently bonded to an oxygen atom, and then that group is covalently bonded to a carbon atom. So very similar to the structure in sugar, and it's why we go through sugars to get to alcohol. Now, ethyl alcohol, or ethanol, is the alcohol that results from the fermentation of sugars by yeast. And it's a good thing because this ethyl alcohol, or ethanol, is an alcohol that we can drink. Now, in mass quantities, it can be deadly, but it is drinkable. And we get to ethyl alcohol depending on the starting materials that we use. So when we use sugars and the right yeast, we can get to ethanol. And that's a big business, as you all know. So I bring this up because, like I said, if we put an OH group on this methyl group, we get something called methyl alcohol. And it's got a red box for a reason I'll explain in a minute. If we add another carbon to the chain, now we're in ethyl alcohol, or ethanol, and that's the ethanol that we drink when we drink alcoholic beverages. Another carbon in the chain is propyl alcohol. That's not such a good thing. And isopropyl alcohol, some of you may recognize that name as the alcohol that's in rubbing alcohol. Also not a good thing to drink. Well, these two, if they're sold in the consumer market, particularly this isopropyl alcohol, has a little bit, now let me draw a line here, of this methyl alcohol. And why is that? Because we don't want people drinking isopropyl alcohol. You can see from the text underneath here, methyl alcohol, or methanol, is toxic. And it's found in a whole bunch of different household and industrial products. What's going to happen? Well, there's morbidity involved and mortality involved. And methanol poisoning usually is accidental, or maybe it's intentional if you're reading murder mysteries. It's in things like windshield washer fluid and gas line antifreezes and carburetor cleaners and blah, 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 blah. And it's just not a good thing to ingest. It's one of the byproducts back in the old days when moonshine was being made. A lot of it had some methyl alcohol in it, and some people just got sick and other people died. So moonshine made out there in the hills of Appalachian country, probably not a good idea, might contain some methanol. So just to be 100% clear, there are also other alcohols that are known as fatty alcohols, and these have a lot more carbons in the chain than 1 or 2 or 3, and they're very beneficial for skin. If you look on your skincare products, you may find cetyl alcohol or stearyl alcohol. These have 14, 16, and 18 carbon chains, and if they didn't have the alcohol function, they would be waxy. But the alcohol function gives them more of a greasy feel. They form a barrier on the skin, and that barrier on the skin holds moisture in, and that's why they're in those products. So they're also alcohols, but they're not alcohols that you want to ingest. Let's talk a little bit about carbohydrates next. You may know that wine is obtained generally from fruit. There are a few other things you can get wine from. Beer and whiskey, or distilled spirits, are from grains. In fact, spirits is basically just beer that's been distilled down to concentrated. And in Japan, sake is a big business, and that is made from rice. So the question is, if they're all fermented, what is the commonality here? Well, because fruit is very sweet, grains we don't think of as being very sweet, and rice we don't think of being very sweet, unless we add sweet things to it, like, say, coconut. Well, carbohydrates in general, you might remember from the beginning of the semester, are the sugars and starches and fibers that we find in fruits and grains and vegetables and milk products. So there's a lot of different forms of carbohydrates. The American Diabetes Association tells us that carbohydrates are the body's main source of energy, because fruits and grains and vegetables and milk products, those are all good things for us to have, particularly when we need energy. And they're called carbohydrates, as you might remember, because they contain carbon, that's where the carb comes from, and hydrogen, that's where the hydrate part comes from, and oxygen gives us this ATE ending in the way that we chemists name things. So carbohydrate basically tells you it's carbon, hydrogen, and oxygen. Now, sugar is not so accessible when you start with a grain or a piece of rice. They're also not so sweet. But the sugar that is used to ferment to make ethanol is part of a bigger polymer that's known as a starch. And in the process, we need a process that's going to break down that starch into monosaccharides, which mono, you might remember, means one. So we need individual sugars that we can ferment, sugar monomers, so that these can do their stuff and turn into ethanol for us. So we here have glucose is a monosaccharide, sucrose is a disaccharide made up of glucose and fructose, and starches are made up of a whole bunch of sugar monomers. So something has to happen to go from these starches with all these sugar monomers to get us to the point where we only have individual sugar molecules that we can use yeast on to ferment and make ethanol. In the natural world, some animals, and I picked on cows to be the one that I'm going to talk about, we all know that cows eat a lot of grass. Grass is made up largely of this material known as cellulose. We don't eat grass because our bodies don't digest grass very well, because we don't have enzymes, microorganisms in our stomach that breaks down cellulose. If you eat a piece of paper, which is also cellulose, our bodies are not going to digest it, and if you eat a lot of paper, it's going to get real uncomfortable. But cows and other animals do have an enzyme that breaks down cellulose so that they can eat it as a food source. We want to go back and remind ourselves that carbohydrates end in OSE. For milk, that would be lactose. Enzymes end in ASE, that would be lactase. That lactase is the enzyme that breaks down lactose. We need a specific enzyme in our body to break down these carbohydrates. And here's the lactase, lactose said again. And all these enzymes do is they clip the polymer into smaller and smaller pieces of sugar until we get all the way to monomers. And since the yeasts need monosaccharides to do their job, these enzymes wind up being pretty important to the process. All right, we're at a point where we're going to take a time out here going into slide 17. So come back for part 2, where we will start our discussion with yeast.